Good morning, Karen. It's Keith, and I'm going to show you a little something about the database I've created. I've actually created two databases. The first one is the AgWeatherNet database, which has 3 tables in it, and I'll explain those in a minute. That's what the purpose of this video is this morning, is to describe the videos in that database. And then there's the actual variety trials database, which I've also built, but I'll talk about that at another time. The reason why I'm talking about the AgWeatherNet tables this morning is because I used the process that they have to hone a import process for bringing in the data from your multiple files and file formats. It's not going to be easy, and I'm trying to avoid a manual data entry process, which would be both time consuming and, given the budget constraints, I'd be spending all my time doing manual data entry. It might be more practical to hire a temp person, pay them a minimum wage, and even then, it's a lot of manual entry. So let me show you what we have here. There are 3 tables in this database. Okay, it is AgWeather Providers, AgWeather Stations, and AgWeather Daily Data. Okay, AgWeather Providers is what we have here, and this is a network of station providers. Stations provide daily weather interval data, as well as other types of intervals. For the purpose of data that we're storing, it's only on a daily basis. And you had suggested that that would be the better format, and I agree. So we have NOAA, we have Eris Weather, which is actually an interesting weather network that I came across. It uses crowdsourcing as its means of gathering weather data, which can be used, all of these can be used as a layer, or it's part of a layering process as necessary for kind of doing overlays on your plots and whatnot, if you choose to do that. For the purpose of today's conversation, we only have AgWeatherNet data pumped in, and there's 2 ways I pumped in AgWeatherNet data from the provider. One is manually, which I've done for Elmira, and that's using their publicly available website to download yearly intervals. And then the second one that I've got is from the analyst from agweather.net provided, and that is for Aswell. Okay, and there's a difference, and I'm going to go into that a little bit. There's a little bit of a difference between the data that the analyst provided me and the data that is on an ongoing basis going to be available for updating the database. This is important because I have an interval of time from a few weeks past the date that the station was created to present time. And then as we go on a year from now, we will want to update the database with more relevant weather data information. So here we have providers, which is a network of stations. And then we have the stations, and this is what the stations look like. And I've sorted this by the name of the station. So we have Elmira and we have Aswell here. Elmira having a station ID of 29 and Aswell having a unique station ID of 33. Again, Elmira was manually brought in the import process from their database, and Aswell was given to us by the analyst. The concept is that it's columnar data, it's spreadsheet or comma delimited CSV data, which is going to be very similar to the process that I'm going to use for doing your forms. Now, I did this first because your forms are not standard. Each one has different columns. Each one, for example, the soil sample one comes on a PDF to you that you provided to me. That would have to be manually entered unless we were able to get the Excel spreadsheet from the lab itself. That would be something that I would be willing to do, communicate with them, and it would be really necessary to avoid manually entering all of this data from soil samples. In the way that the form was presented to me, that you have from the lab, it may not be possible to do, at least it might be out of my skill set range, to set up a data conversion based on the way that that form is presented. So if we can get an Excel spreadsheet from the lab of all your historical soil sampling sites, I can massage the data, pump it into your database. And on a kind of tertiary note, I think it's important that you are doing this database because if individuals were to leave the program, that's a lot of accounting for spreadsheets and various Google Docs and Google Sheets that would need to be accounted for and then reanalyzed or reviewed. So I think that having a centralized database at this juncture was probably a good idea. So let's move on. We have AgWeather providers, which is the foundational element of this particular database. AgWeather stations, which correspond to a network of providers. The relationship is one-to-many, one provider for multiple stations. Each provider has stations. And then the actual AgWeather daily data. And we're storing in daily intervals, not hourly, not monthly, not yearly, although you can run queries to do those calculations if you need to, based on the daily data. Because if I show you what that looks like, here we are. You are recording station ID, in this case Elmira, which we already know is 29, and then Aswell, which is station number 33, and these are being stored on a daily basis. And here's, you can tell, it's chronologically increasing by day. And so this is the data I've pumped in, and it stores average temperature and a number of other variables. But here's a problem that I saw with the station data, that the difference between manually downloading it and the bulk data that was provided. The bulk data is necessary to avoid having to enter this manually. And so what they provide with the bulk data, which is what I got for Aswell, is in degrees azimuth from. So wind direction in this case, which is what the variable is recording in this column, I noticed that there's a problem, and it's a big deal if you're doing soil erosion research and you need to understand the average wind direction for that station location. That's alliterative. Here, in this case, 358 degrees is relatively a northern heading on the azimuth, and that measures degrees from. Wind direction is recorded by degrees from on the azimuth. And here, the wind is coming from the north, going to the south. Okay, the south is 180 degrees on the compass heading. Okay, so we know that if it's coming from the north, in this case 358 degrees, it's going to the south. The problem is that here, this is represented by an alpha character. They are representing the dichotomous opposite information, and I verified this with Elmira data downloaded from their website. So Elmira data for this particular day, okay, station number 29, okay, versus station number 23, which was from the analyst, the bulk data. So the manually entered data, which is necessary for updating the website once we put the bulk in, the bulk data, the manual process, which will be used to update the database, shows an alpha character. That alpha character represents the degrees where the wind is going to, okay? Because if you looked at Elmira's data, it would show that the data point in here was actually 180, or approximately 180 degrees on the azimuth, which, as we know, 180 degrees on the azimuth measures the wind coming from, okay? And so it's totally different. And so I've put into the metadata of this table, and I can show you that here in the design view. So this describes the actual properties of the table. What this table description is date record entered for identifying age of data, blah, blah, blah. All right, and so then for this column, in this case, wind direction here, there should be metadata that says, here it is, data bulk imported is represented in degrees from wind direction. Data manually downloaded is alpha and shows direction to. And I put that note in there so that anybody who would in the future do some analysis that requires wind direction would understand that there's something off about the data. Now I can fix that. It's going to take more time, but that's just what the analyst provided, and there's a problem moving forward with that. And I've already addressed it with him, but he didn't solve the problem. So that's all I want to talk about with that. So as long as you understand that here we have at its foundational root in a relational database, you have providers of a weather network, and each weather network has a multiple number of stations which records average daily data. Okay, and so that's really what this is about, and I'm going to show you next the actual import process. Okay, and that will be the next video.